an ideal ordinary Portland cement manufacturing and testing facility as per IS 269. The cement manufacturing process is divided into 7 stages. Mining. The cement manufacturing process starts with the mining of cement-grade limestone. At limestone mine, open-pit mechanized mining techniques are used to exploit the cement-grade limestone. The mined material is loaded by excavators on the dumpers and transported to the crushing plant. Crushing. The crushed material is then transported through cross-belt analyzer by conveyor for longitudinal pile formation with movable stacker. Cross-belt analyzer provides minute-wise elemental analysis of crushed limestone with Californium 252 prompt gamma neutron activation analysis technology for online quality of limestone. Pre-blending. Pre-blending equipment, stacker and reclaimer are installed to get constant quality of raw material. With the help of reclaimer, longitudinal pile reclaimed vertically and convey the material to the blending hoppers. Raw material extracted from the hoppers with controlled flow and convey to the vertical roller mill. Grinding in VRM. The vertical roller mill grinds the material with optimum fineness and the ground material transported to the 6-stage preheater by elevator. The pet coke or coal grinding is done with another vertical roller mill for pyroprocessing. Pyroprocessing. In pyroprocessing, the fed material passes through the 6-stage preheater and burned in rotary kiln and cooled in cooler. The outcome of the process is the key ingredient of the cement, that is clinker. Clinker grinding. To achieve the narrow particle size distribution, the clinker mixed with the gypsum and ground with high efficiency separator circuit of vertical roller mill. The ground cement stored in cement silos by closed air slide conveying system. Packing and dispatch. The last process is cement packaging. The cement is extracted and bagged by consistent high accuracy electronic rotopackers and packed cement bags loaded to the trucks with fully automatic front loader. Finally, the cement bags transported to the market by truck. Robotic lab. The technology that truly sets the plant apart is the unique, fully automatic robotic lab. It automatically collects the samples from various stages at predetermined intervals and pneumatically transports from auto samplers to the analytical point through well-laid pipelines, which is then automatically processed for pellet preparation and analyzed by the highly accurate analytical equipment. Then analyze data transfer to the centralized control room to take corrective action in manufacturing process whenever required. Chemical testing. In order to make best quality cement, it's become necessary to study the behavior of final product. Here is well-equipped chemical lab. All chemical test is performed as per IS 4032. Loss on ignition. To determine the loss in mass percentage of cement on ignition, take 1 gm oven dried sample and heat it in a waked crucible by placing in muffle furnace at 900 degrees Celsius to 1000 degrees Celsius for 15 minutes. Now cool and wake the crucible with sample. Again heat for 5 minutes in muffle furnace and reweight. Record the loss in weight as the loss on ignition and calculate the percentage of loss on ignition. Insoluble residue and sulfuric anhydride. To determine the percentage of insoluble residue in the cement, take 1 gram sample in a 250 ml beaker with 25 ml distilled water. Break the lumps with glass rod and add 10 ml 1:1 ratio hydrochloric acid. Then heat and digest for 15 minutes just below boiling on hot plate. Then cool and filter with 40 ashless filter paper and wash the residue with hot distilled water. Preserve the filtrate for sulfuric anhydride testing. Digest the filter paper with residue in 30 ml hot water and 30 ml 2N sodium carbonate. Digest for 10 minutes below the boiling point. Filter and wash with 1:99 ratio hydrochloric acid and finally the hot water to make it chlorides free. Ignite the residue in pre-baked crucible at 950 degrees Celsius. Cool and bake. The mass remain in the crucible is insoluble residue. Sulfuric anhydride. To determine the percentage of sulfuric anhydride, take reserve filtrate of insoluble residue. Boil for few minutes and add 10 ml barium chloride slowly from the edges of beaker. Digest the solution on steam bath for 4 hours or overnight. Filter and wash with hot water till chloride free. Then ignite residue in pre-baked crucible at 850 degrees Celsius. Cool in a desiccator and bake the residue. Sulfuric anhydride percentage then calculated from the crucible weight difference multiplied by 34.3. Silica. For silica determination, take 0.5 gram sample in 250 ml beaker and add 10 ml distilled water and break lumps by glass rod. Add 10 ml 1:1 ratio hydrochloric acid and heat the sample till completely get dissolved. Then evaporate the solution to dryness. After cooling, add 10 ml hydrochloric acid and 100 ml distilled water and boil up to 10 minutes. Filter the solution with filter paper and wash it with hot water till residue get chloride free. Preserve the filtrate for determination of Al2O3, Fe2O3, CaO and MgO. Transfer the residue in pre-baked platinum crucible and ignite at low temperature until the carbon of paper is completely consumed without inflaming and finally ignite at 1100 degrees Celsius. Cool and bake and treat residue for reducing impurities. Add 2 ml distilled water and 10 ml hydrofluoric acid and 2 drops of H2SO4 and evaporate to dryness and finally heat residue at 1050 degrees Celsius for 2 minutes. Cool and bake. Ferric oxide. To determine the ferric oxide, take 25 ml of solution preserved as silica filtrate in 500 ml conical flask. Add sulfosalicylic acid and 1:6 ratio of ammonium hydroxide till color change to yellow. Then add 1:10 ratio of hydrochloric acid up to color change to wine red at pH 1 to 1.5 approximately. Warm the solution at 50 to 60 degrees Celsius and titrate with 0.01 EDTA. Note the reading at a point on which pink color change to colorless solution. Preserve this solution for alumina determination. Alumina. Take preserved solution obtained after ferric oxide determination. Then add 20 ml of EDTA solution, 1 ml phosphoric acid, 5 ml 1:3 ratio of sulfuric acid and 2 drops of thymol blue indicator. Then add ammonium acetate solution by stirring until the color of solution change from red to yellow. Then add 25 ml excess ammonium acetate to obtain pH approximately 5.5 to 6. Heat the solution up to boiling for 1 minute and let it cool. And about 50 mg of solid xylene orange indicator and titrate with bismuth nitrate solution until color changes yellow to brick red. Then add 2 to 3 ml of bismuth nitrate solution in excess and titrate with 0.01 m EDTA solution till color change from brick red to sharp yellow color. Alumina percentage then calculated by the formula. Calcium oxide. Take 10 ml of reserved silica filtrate solution in a conical flask. Add 10 ml glycerol, 1:1 ratio, and 5 ml dimethylamine. Shake well and add 10 ml sodium hydroxide and shake well to adjust pH 12 or slightly more. Add approximately 50 ml distilled water and 50 mg of solid Paton. Reader's indicator. Titrate with EDTA to a color change from wine red to clear blue. Note down the volume used of EDTA solution. Then calcium oxide percentage calculated by the formula. Magnesia. Take 10 ml reserved silica filtrate solution in a chemical flask and 5 ml triethanol amine with shaking and 20 ml buffer solution. Add 50 mg of thymol pethaxolone indicator and 50 ml distilled water and titrate it against EDTA until the color change from blue to pink. This titration gives sum of calcium and magnesium oxide percent in the solution. Titrate value of magnesium oxide is obtained by subtracting the titrate value of calcium oxide from its titrate value. Physical testing. Here is well-equipped physical lab for various cement testing as per the IS 4031. Various physical tests performed at physical lab in standard laboratory conditions are: specific surface area. This test is performed as per IS 4031 Part 2 to determine the specific surface area of cement. Weigh the calculated quantity of cement and add it to the permeability cell having small perforated disc and filter paper. Then put another filter paper and press the material with plunger and fix the cell on the Blaine's apparatus. Evacuate the air in the U-tube through the side tube using the aspirator bulb until the oil inside the U-tube reaches the level 1. Close the side valve and monitor the oil as it starts to come down. Using stopwatch, measure the time taken for the oil to come down from level 2 to level 3. The specific surface area then calculated with the formula S is equals to K under root T. Consistency of cement. This test is performed as per IS 4031 Part 4. To determine the consistency of cement, weigh the cement, add measured quantity of water and gauge for 3 to 5 minutes. Fill the mold and check the penetration with wicket plunger. Repeat the process till required penetration 5 to 7 mm is achieved. Calculate the water in percentage. Soundness by autoclave. This test is performed as per IS 4031 Part 3. Cement test specimens are prepared in 25 multiply by 25 multiply by 250 mm mold with water equal to consistency. Specimens are cured in the mold at 27 plus minus 2 degrees Celsius and 90% RH for 24 hours. Remove the specimen from the mold and measure the length with length comparator and place in autoclave. Raise the pressure to 21 kg per square centimeter in 60 to 75 minutes and maintain this pressure for 3 hours. Cool to room temperature and again measure the length. From increase in length, autoclave expansion is calculated as percent expansion. Initial and final setting time. This test is performed as per IS 4031 Part 5 to determine the initial and final setting time of cement. Prepare cement paste using water 0.85 times of consistency in 3 to 5 minutes. Start stopwatch when water is added. Lower the needle gently until it comes in contact with surface of the test block. Then quickly release it. Note the penetration. Record the time when penetrate is 5 plus minus 0.5 mm from the bottom. This time represents initial set. Replace the needle with annual attachment to measure final set. Go on checking the final set at different intervals. Final set is obtained when needle makes impression while attachment fails to do so. Note the time. This time represents final set. Soundness by Le Chatelier. This test is performed as per IS 4031 Part 3. Prepare cement paste using water 0.78 time of consistency. Place mold on glass sheet. Fill with cement paste and cover with another glass sheet and place small weight on covering glass. Place the assembly in water at 27 plus minus 2 degrees Celsius for 24 hours. Measure the distance between indicators. Boil for 3 hours. Cool and again measure the distance between indicators. Change in dimension represents Le Chatelier expansion in mm. Compressive strength. This test is performed as per IS 4031 Part 6. Take 200 gram of cement sample and add 3 type of standard sand 200 gram each. Mix it well with gauging towels for 1 minute. Then add the calculated quantity of water and mix it well with gauging trowels for 3 to 4 minutes. Same as you can see in the video. Simultaneously, keep the mold ready by applying oil on inner side of mold. Then fix this mold on vibrating machine by tightening the nuts on vibrating machine. Then add cement sand mixture in the scoop and fill it in mold on vibrating machine in 2 layers and press the mixture with poking rod. Remove the mold from vibrating machine after 2 minutes and smooth the surface of mold with the trowel. Keep the finished mold in moist closet for 24 hours. Then remove the cube from the mold and immediately submerge in the clean water at the temperature of 27 degrees Celsius. Test 3 cube for compressive strength in compressive strength testing machine for each period of curing mentioned under the relevant specification of hydraulic cement. Concrete lab. In order to check the cement quality with aggregates, it is necessary to study the behavior of final product through concrete laboratory tests. Here is well-equipped concrete lab. AFR laboratory. To set the quality milestone of cement in every aspect, here is well-equipped AFR lab to test the various fuels used in pyroprocessing. The lab has highly sophisticated equipment for the testing which gives very fast and accurate results with very less efforts.